This is lesson 8-1, operations with algebraic expressions. So this lesson is going to be largely a review from Unit 1, lessons 1-4, 1-5, 1-6, and 1-7. All of these notes you've seen before. I do want you to write them down again because it's important that we remember vocabulary. For algebraic expressions, a one-termed algebraic expression is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and anything above that we just call a polynomial. Like terms have to have the same variable or variables. They can have more than one variable. They also have to have the same exponents assigned to those variables. And the exponents can be different. The exponents cannot be different, and they have to be the same ones assigned to the variables. So, for example, you cannot have something like 3x squared and 4x to the third. They are not like terms because, yes, they have the same variable, but they do not have the same exponent assigned to those variables. The only thing that does not matter when we discuss like terms is the coefficient, the number in front of the term. Here's your rules for adding and subtracting algebraic expressions. Again, you can only add or subtract like terms. If you have like terms, you add the coefficients and you leave all of the variables and the powers or exponents alone. If there is no coefficient that's in front of a variable, you may assume that a 1 is there. If you have polynomials, you want to use your vertical method or horizontal method, and you should refer to lesson 1-4 if you don't remember either of those methods. Here's some examples for you to try. It's the exact same ones, except one is addition and one is subtraction. Pause the video at this point to give yourself a chance to try it on your own. Here are your answers. So I'll do one with the vertical method and one with the horizontal method. I'll do the addition with the vertical method, and that's 6x squared minus 4x plus 5. The plus will be out here, and then 3x squared minus 8x plus 10. Now, this vertical method is similar to what you did in kindergarten when you were adding simple numbers. But what I can do here, I'll start all the way at the right, and positive 5 plus positive 10 gives me a positive 15. Negative 4 plus negative 8 gives me a negative 12, and the x stays the same. We don't touch variables or their exponents. And 6 plus 3 is 9, so we have 9x squared minus 12x plus 15. I'll be honest with you, that is not my favorite way of doing that. I'm not a big fan of the vertical method. I prefer the horizontal method, which is what I'll do with the subtraction. So we have 6x squared minus 4x plus 5 minus 3x squared minus 8x plus 10. I first then put ones in front and distribute what I need to distribute. It's a positive 1 in the front and negative 1 in the back. So we have 6x squared minus 4x plus 5 minus 3x squared plus 8x minus 10. Then we can go through and combine all the like terms that we see. I see a positive 6 and a negative 3x squared. That's 3x squared. I have a negative 4x and a positive 8x. That gives me a positive 4x. And a positive 5 and a negative 10 gives me a negative 5. So that'll be my final answer for the second one. Your rules for multiplying a monomial: you first want to multiply your coefficients, multiply the like variables, and you need to remember your exponent rules from Unit 1 and our review of them in the last unit. If a certain variable only exists in one of the monomials, you want to leave that variable alone. If you're doing polynomial times monomial, you want to remember your distribution property techniques. When you're multiplying two polynomials, I typically use the distribution method. If you want to see the other methods that you can use, you need to refer to lesson 1-7. The distribution method refers to taking the first term and that we should have in there first term of the polynomial and distribute it to the entire second polynomial. Remember, these could be bigger than binomials. Now, I happen to have two binomials here, and that's what I do is I'm taking the x and I'm distributing it to the other x and the -8 to get x squared and -8x. The second one, then you're going to take the second term, in this case of a binomial, but you could say again, polynomial, and distribute it to the entire second polynomial. And I'll do that here with the 5. And then we'll combine all the things together. We add all of those products together. These are the 4 products right here. We add them together and then combine any like terms, which we have in the middle. -8x and 5x gives me a -3x. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. Here are your answers for the first one. We have 3x squared times 4x to the third. I'm going to multiply the coefficients. That gives me 12. And adding the exponents, those are our exponent rules, 12x to the 5th for the first one. Notice again that these are all expressions, by the way, and I have yet to use an equal sign anywhere. And you want to keep that as a central theme as well. The second one, we have -2x to the third times the quantity 3x minus 6y. We're going to distribute this all the way throughout. And so we end up with -6x to the fourth plus 12x to the third y. Again, nothing we could do with the x and y's, but we could certainly multiply the -2 times the -6 to get the positive 12. That is my answer for that one. The third one, we're going to, again, double distribute because we only have 2 to distribute here. So I have 2x minus 5 and 3x plus 4. I'm going to distribute the 2x first. That gives me, not 2x, it gives me 6x squared plus 8x, and then I'll distribute the -5 to both. So now I have minus 15x minus 20. Combine the two like terms in the middle. Typically, those like terms are going to be in the middle for you, but be careful if they're not. We end up with 6x squared minus 7x minus 20. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.